The James Webb Space Telescope has unveiled the clearest image of Proxima B ever captured, offering extraordinary insights into this potentially habitable exoplanet. Its findings ignite our curiosity as we journey deeper into the cosmos, hoping to uncover whether this mysterious world could one day be our second Earth. Orbiting within the habitable zone of its star, Proxima Centauri, Proxima B is no ordinary planet. Located just 4.2 light-years from Earth, it's a tantalizing candidate in the search for alien life. Covered in mystery, this rocky world raises a fascinating question. Could it harbor oceans and perhaps even life? But the story doesn't end there. Proxima Centauri B isn't alone in its star system. It has a known companion, Proxima Centauri C, and possibly others yet to be discovered. This red dwarf system might still hold secrets that have yet to come to light. Interestingly, Proxima B receives a similar amount of stellar energy from its star as Earth does from the Sun, sparking further speculation about the possibility of liquid water and life on its surface. As we venture beyond our solar system, we're discovering an astonishing variety of exoplanets, planets that orbit stars other than the Sun. With over 200 billion stars in our galaxy alone, the possibilities are endless. Some planets even drift freely through space, untethered to any star, cosmic wanderers in a vast sea of darkness. Among these, Proxima Centauri B continues to capture the imagination. It completes a full orbit in just 112 Earth days, and lies much closer to its star than Earth does to the Sun. This proximity creates a unique dynamic. One side of the planet is locked in perpetual daylight, while the other remains in eternal darkness. To understand Proxima B, we must also understand its parent star, Proxima Centauri. Part of the Alpha Centauri triple star system, this stellar neighborhood includes Rigil Cantoris, Alpha Centauri A, and Alpha Centauri B, a binary system made up of G and K-type stars. These two stars appear as one bright object in the constellation Centaurus and rank as the third brightest star in our night sky, with a peak luminosity just under 2.7. Proxima Centauri, also known as Alpha Centauri C, is a red dwarf M-type star, located approximately 0.21 light-years from its binary companions, roughly 4 times the Earth-Sun distance. As its name suggests, Proxima is our closest stellar neighbor, discovered in 1915 by Scottish astronomer Robert Innes. Despite being so close, it's invisible to the naked eye due to its dim magnitude of 11.13, well below the human visual limit of 6.5. Yet, don't let its faint glow fool you. Red dwarfs like Proxima Centauri are incredibly efficient stars. While they don't emit much light or heat compared to stars like our Sun, their internal convection allows them to burn fuel slowly, granting them lifespans of trillions of years. Proxima Centauri itself is expected to remain a main sequence star for another 4 trillion years. However, its suitability for hosting life is still a matter of debate. As a flare star, Proxima Centauri frequently unleashes violent bursts of radiation. Its habitable zone, the range where liquid water could exist, is much closer to the star than Earth is to the Sun, likely somewhere between 0.023 and 0.05 for Australian dollars. But being in the habitable zone isn't everything. Proxima B is constantly bombarded by intense ultraviolet and X-ray radiation from its host star, far more powerful than what Earth receives. This harsh radiation is capable of stripping away even the lightest atmospheric particles, such as hydrogen, nitrogen, and oxygen, the essential ingredients for a stable, life-supporting atmosphere. And without a protective atmosphere, Proxima B's surface will be vulnerable to extreme space weather and temperature fluctuations, making the existence of liquid water and life highly unlikely. So, while Proxima B may resemble Earth in some ways, its ability to support life remains doubtful. It may be a planet of endless promise, but also of unforgiving realities. Scientists remain cautiously optimistic about Proxima B, as numerous factors still suggest it may be uninhabitable. Nonetheless, the mission to uncover the planet's secrets continues, and hope persists in the scientific community. One of the most powerful tools in this endeavor is the James Webb Space Telescope. After years of anticipation, it was launched in 2018 and is now helping researchers investigate whether Proxima B might support life. Yet, as is often the case in science, things are rarely straightforward. Several critical adjustments were needed to ensure that the James Webb Telescope could produce accurate and reliable images. As Habitable, a theoretical physicist at Harvard, explains, if a planet like Proxima B absorbs light from its star, it can also re-emit that energy as infrared light. The James Webb was specifically designed to detect infrared emissions. This allows it to search for telltale signs, such as water or atmospheric patterns, that may hint at habitability. However, even the presence of an atmosphere doesn't guarantee life. Ed Turner, an astrophysicist at Princeton University, warns that Proxima B could resemble Venus, a planet with an extremely dense atmosphere and surface temperatures that are hostile to life as we know it. The journey to understand Proxima B is filled with challenges. While the James Webb Telescope offers promise, it's only one piece of the puzzle. Space exploration is expensive, and scientists face mounting pressure to maximize their findings. Still, the potential reward, the chance to explore potentially habitable worlds so close to Earth, is immense. Proxima B's proximity to Earth makes it particularly fascinating. Located in the habitable zone of its star and roughly Earth size, it could theoretically support life. This makes it one of the most compelling targets in the search for life beyond our solar system. Though we can't visit it yet, it remains high on the list for future interstellar missions. But getting there is no small feat at current spacecraft speeds, such as those of Voyager 2. It would take an estimated 75,000 years to reach the Proxima Centauri system. Fortunately, innovative ideas like solar sails offer hope. These ultra-thin sails harness the pressure of sunlight for propulsion, eliminating the need for fuel and potentially reducing travel time dramatically. Even more exciting is that this cutting-edge technology could provide deeper insights into Proxima B's environment. For instance, the James Webb Telescope can detect infrared emissions even if they're just 5% as bright as the planet's daytime side. A remarkable feat, especially considering that Proxima Centauri is a much dimmer star than our Sun. There's even speculation that if Proxima B harbors an advanced civilization, it might use orbital mirrors to reflect sunlight from the day side to the night side of the planet. A mind-blowing idea that shows just how imaginative and expansive our theories about alien life have become. And Proxima B is just the beginning. The universe is teeming with exoplanets of all types. Some are massive gas giants, so-called superjupiters, that dwarf even Jupiter in our own solar system. Others are hot Jupiters, orbiting extremely close to their stars and enduring blistering conditions. Still, others resemble Earth in size and composition, stoking dreams of habitable environments elsewhere in the cosmos. In short, our quest to explore and understand Proxima B is part of a much larger journey, one that may one day answer the ultimate question. Are we alone? Temperatures hot enough to melt metal and planets shrouded in mystery. Imagine witnessing a planet up close where temperatures soar high enough to melt metal, its skies dominated by violent storms and searing heat. Beyond the massive gas giants, astronomers have also identified Neptunian exoplanets, worlds similar in size to Uranus and Neptune. These include hot Neptunes and mini-Neptunes, which are typically smaller and orbit much closer to their host stars than gas giants do. Many of these mysterious worlds have atmospheres that remain difficult to study due to their distance and conditions. Then, of course, there are the Earth-like exoplanets, some smaller than Earth, others up to twice its size. Among them are super-Earths, planets with masses more than double that of Earth, but still lighter than Neptune. One of the most intriguing examples is Proxima Centauri B, a super-Earth orbiting the star Proxima Centauri. With an estimated mass about 7 times that of Earth, it's located relatively close to its star, but still outside the star's habitable zone. But Proxima Centauri B isn't alone. It has a sibling planet, Proxima Centauri C, which lies farther out with an orbital period of around 5 Earth years. This planet was discovered in 2020 using pre-recovery data from the Hubble Space Telescope. What's particularly fascinating is that Proxima Centauri C may be unusually bright, possibly due to a surrounding ring system. And the surprises don't end there. In 2019, astronomers detected a shift in Proxima Centauri's orbital motion, suggesting the potential presence of another planet, Proxima Centauri D. If confirmed, this planet would be roughly the size of Mercury or Mars. The Proxima Centauri system, like many others, could host a dynamic array of planets, each contributing to our growing understanding of the cosmos. Just picture a night sky filled not just with stars, but countless planets, each with its own unique orbit, composition, and mysteries waiting to be solved. The universe is a treasure trove of surprises, and exoplanets are among its most fascinating discoveries. Though we don't yet know the full number of exoplanets in existence, we do know they're out there, just as surely as we know the stars that shine across the sky. However, detecting them comes with its challenges. Many exoplanets are hidden in the glare of their parent stars, making observation incredibly difficult. Thanks to modern technology, though, direct imaging has become possible. To directly image an exoplanet, it must meet several criteria. It needs to be large enough, far enough from its star to avoid being lost in its brightness, and young enough to still emit detectable heat. These constraints mean only a limited number of exoplanets can be seen this way, but those that can offer profound insights into their nature and structure. Most exoplanets are found indirectly, through the effects they have on their host stars. Their gravitational pull can cause a star to wobble slightly, an effect known as radial velocity, which astronomers can measure. NASA's Kepler Space Telescope uses another method called the transit method, detecting exoplanets by observing the slight dimming of a star's light as a planet crosses in front of it. This technique has provided crucial data about exoplanet size, orbital distance, and surface temperature. Here are a couple fun facts. Over 22% of Sun-like stars are believed to host Earth-sized planets in their habitable zones. The TRAPPIST, one system contains 7 rocky planets, some of which may have water on their surfaces. And just like our own solar system, many of these distant planets could have natural satellites, so-called exomoons, orbiting them. With over 4,000 exoplanets officially discovered and countless more suspected, we now know that planets are not rare, they're cosmic commonplace. Among them, hot Jupiters are some of the easiest to find due to their large size and rapid orbits. But the search continues for many other, more elusive types. One of the biggest breakthroughs in recent years came thanks to NASA's James Webb Space Telescope. This revolutionary instrument is helping to uncover the universe's deepest secrets with each new observation. One of its most groundbreaking findings was the first definitive detection of carbon dioxide in the atmosphere of an exoplanet outside our solar system. This exoplanet, a gas giant orbiting a sun-like star 700 light-years away, offers important clues about planetary formation and potential habitability. NASA Administrator Bill Nelson called the discovery a new lens through which to view the universe, sparking excitement across the global scientific community. And that's just the beginning. The James Webb Space Telescope is currently observing the universe in infrared, revealing things we've never seen before. One of its recent observations includes the Object 110 IROS-4, where light from this young source illuminates delicate clouds of gas and dust. Orange patches seen in the background are the distant light of stars blocked by icy material in the clouds. This study is part of Webb's Ice Age project, which traces how ice forms and evolves in space, eventually becoming icy comets. Webb has also captured, for the first time, the inner structure of a dusty disk surrounding a nearby red dwarf star, something previously invisible at these infrared wavelengths.